Hi, my name is Jorge Torres. I'm the CEO at MindsDB, and I'm here to talk to you about database artificial intelligence and the fantastic work that we've been doing with MariaDB ever since we started with this idea, and all the advancements that we've made so far that hopefully you will find super interesting and useful for your projects, your ideas, and to make better decisions. Which jumps into the fundamental question that we ask ourselves: why database artificial intelligence? As you know, databases are fantastic decision-making tools, and it makes sense to power them with machine learning capabilities of today so that those users, those database users, can actually leverage that power to make even better decisions. Database artificial intelligence is to augment the databases with AI capabilities, and we start with the machine learning capabilities. MindsDB is the leading DBAI platform today, and we are actually super excited to show you all the things we've done to tackle very interesting problems that you already have or that you probably have when you try to forecast from information that you have in your database. MindsDB plus MariaDB provides this abstraction for the machine lifecycle. Essentially, it allows you to do all the steps of machine learning all within SQL: the data preparation, the machine learning model, and the model deployment. Of course, the data preparation is something that you can already do with MariaDB because databases are inherently the most powerful tools to do data preparation. The concept that we introduce here is a concept called AI tables. Now, the best way for me to actually introduce you to this concept is to give you an example. Imagine that you have a simple table that has income and debt. If you were to visualize this table, you will see what you have on the left hand or the right-hand side of this image. And every single row that you have in that table represents a dot. Databases are designed to give you responses to statements that match a record that you have in your database. However, they're not designed to give you approximations. So if you query for something like, what is the actual income for, or what will be the debt for an income of 90,000, you're going to get no results. Anyone that has done machine learning modeling understands that you can build a hyperplane that fits that data. And the idea that we have is, well, it'd be very interesting if we could create that model or fit that line the same way that we actually, or with a syntax that is very similar to that we use to create a view. In this case, you can tell it you want to create a predictor. You want to name this predictor debt model, and you want to train this predictor from the table income table. And you actually want to learn how to forecast the column debt. Of course, this is a simple approximation of what you can do with MindsDB. If your table is more complex, if the type of information you want to forecast is also more complex and the number of columns that you have, MindsDB can handle this, as well as if you know what you're doing in machine learning, you can specify what type of model you want to use, how you want to mix the data, how you want to encode it. But by default, MindsDB uses super powerful AutoML capabilities, so you don't have to if you don't want to or if you don't know how to. Now, once you've trained a model, then you can actually query this model the same way that you query a table. You can select, in this case, income, debt, and the predicted value from the model that you want to have, where the income in this case is 90,120, and you get an approximation for this. You actually run the model with the input that you had on the word statements. This, of course, can be extended to much more complicated problems, and we'll jump into one of those. But the interesting thing here is that if you actually use AI tables for your machine learning capabilities, then you've accomplished to do all of the machine learning lifecycle in SQL. Of course, if your data is in the database, you figured out how to do the data acquisition. You've already figured out how to do the data cleaning and the labeling of your data, because MariaDB, of course, having a schema forces you to make sure that your data somehow is clean. And then, of course, after every single query, what you have is columns, and those columns are features. Then MindsDB can take care of the modeling with that statement that allows you to create models the same way that you create a view, or in a similar way that you create a view, It can handle the model selection, the hyperparameter optimization, the ensembling, the model validation with its AutoML capabilities, but you can also specify that through the same simple syntax that we abstract for you. Now, the cool thing here is that in databases, the concept of deployment is very instantaneous. As soon as you do create table, create view, those objects are living things within the database. And therefore, the same thing happens when you do create a model or create a predictor. That model is real for you to query as soon as the training is done. You don't have to think of any deployment. And the only things that you have to care about are the same things that you care about when your data is actually changing. If the schema changes, you may want to create a new model. If your data distribution changes, you may actually want to update the model. Now, as we start doing this with databases, we start to realize that databases come with very specific problems that are hard even for very sophisticated machine learning practitioners. Where what you want to forecast is not actually a problem of taking into account just one single row. In this case, let's imagine that you want to forecast inventory from your database. The information that you need to actually forecast this is contained in a history of the inventory units that you have over time. And therefore, the information that the model needs to train, it's not actually contained in one single row, but in multiple rows. This falls within the category of time series. And the interesting thing is that in databases, they get a little bit more complicated than that. You usually don't have just one single column. It's just one to for inventory, but you also want to take into account a column, which is the price of the inventory at the given time, which is a usual thing that you find in databases. This turns these models not only into time series models, but also multivariate time series, which brings the barrier a little bit higher for those that want to build this on their own. Now, the interesting thing here as well is that these problems have a problem of cardinality usually as well. That is that your data is partitioned by, in this case, say a product ID. What this means is you could have in one single table thousands, hundreds, or hundreds of thousands of individual time series that are partitioned by the product ID. You will have as many time series as products you have essentially. And this makes it so that if you're going down the traditional routes, you may actually be inclined to train a model for each partition, which tends to be not viable when you have thousands or hundreds of thousands of those. MindsDB is probably the most sophisticated tool out there for this type of problems where you have time series, multivariate, high cardinality, which are very common problems in your database. And therefore, we're very excited to show you how you can do this. Let's solve this problem. Now, MindsDB allows you to create a model, as we talked about before, in a very similar syntax to that of creating a view. In this case, you want to create a predictor inventory model. You want to train it from the inventory table, and you want to forecast the units in inventory column. Now, you're also telling it that this is a time series problem. So you're ordering it by the column date, and that you're grouping by or partitioning it by the product ID column, that you want to take into account for every single prediction, the last 20 rows of that partition, and that you want to forecast 3 rows in advance. Say you want to forecast the inventory for the next 3 days in this particular case. Once this model is trained, you can actually join that model with another table or the table you trained it from to actually make both predictions or time series predictions. Let's see how this looks like. Imagine that you actually want to forecast for the inventory given, products where the date was greater than 9/2021, and the product ID is iPhone. Let's do the left-hand side of the join, which is, selecting from that table, just the usual things that you do when you select from a table, when you pass the constraints. And what you actually want to do here is you want to forecast past 9/21/21. Now, what you do here is you join the model with the query that you just saw, and MindsDB does magic behind here. So you're telling it to join with the inventory model that we just trained, and that you want to add a new column, which is the predicted value for inventory. And you get the results like this. This is super interesting because you didn't have to do any of the data preparation for the windowing, the moving window, and as well having to run the model itself all you have to treat is this model as another table that you joined with the table that contains the information for your forecast, and you actually get real-time forecasting capabilities on the fly with MindsDB. So I hope that you can get to try it. And if you want to try it, you can actually go to our GitHub repository, install it via Docker, or you can try it on our cloud.mindsdb.com. It's early, but we'd love to hear your feedback, and we'll be really excited to know and to hear what you're going to do and what you're building. Lastly, I think that one of the feedback that we've been getting from people is that most machine learning practitioners, they also have machine learning models that they would like to access through the database. That's why for the next version of MindsDB, we'll be publishing a capability of creating a model as a table in the database, but actually allowing to point MindsDB to a URL if your model has been deployed with Razor for MLflow into a single web service. And this brings the capabilities of you to bring your own models into the database as well. Anyway, we'll be looking forward to see you in our community. So please join us in github.com/MindsDB. And we'd love to hear what you have to say, your ideas. At the end, we're building this for you, and we will love to know what problems you have that you want to solve in machine learning and that you would like to solve through MindsDB. Thank you so much for joining this talk, and we'll see you soon.
Hi, Costa, and thank you for a great presentation from MindsDB. Costa here will be filling in for Jorge that couldn't attend this Q&A session. Costa, would you like to present yourself to the audience a bit?
Yes, sure. My name is Costa. I'm part of MindsDB team, and I'm taking care of community here at MindsDB.
Yeah, okay.
Happy to be here.
Yeah. Costa, it was a great talk. And it's cool to see actually someone taking the lead into innovating with machine learning and AI for databases. Could you please tell me what kind of users MindsDB is aimed at? What kind of users will get the biggest benefit from using your project?
Sure, thanks. Of course, it's a good question. Actually, we are building MindsDB with a mission to democratize machine learning. And this means that users who we are targeting are like people who have their predictive needs and who know their data, but probably they don't have enough or like deep knowledge of machine learning tools out there. And of course, they know SQL and database where their data is stored. So actually, MindsDB allows people to make those like predictions powered by machine learning for such people without even having to know like all the deep dives of machine learning itself. So, of course, you need to know some basic concepts like what means the model training. Yeah, so you need to kind of feed the historical data into the model. But actually, that's all. You just do everything through SQL. But from another hand, we also understand that there are people who might want to use this in a kind of enterprise environment, in a production environment where there are some data science teams in place, machine learning engineers, some maybe existing models people might have, and they want to leverage it from database perspective. Today, classical machine learning approach is treating models like an application. So you need to feed the data to this model. So you need to, not usually people take some like data from where they store it to pandas data frames, like massage it, and then feed it to the model. And during the whole life cycle of the model, you need to actually keep this ETL pipeline also maintained. This is one of the most annoying and difficult machine learning tasks for machine learning engineers. From another side of things, deploying the model is also requiring a lot of effort. You need to build some kind of integration or API from the model to your application. And you also need to maintain it. And this is an extra work for your IT departments to actually keep this working.
Yeah.
And MindsDB allows to do it from just a SQL perspective. All you need to do is just query the model make a SQL statement to train and SQL statement to query the model. And
it seems to have a pretty low entry barrier, and that's what I like about it. And I've seen it in Jorge's presentation. But Jorge also mentioned that it's possible to pick a specific model, to customize it. So that's some side of features you build for bigger companies that have kind of a data science department, right?
Exactly. So you can start with MindsDB easily, even if you don't have data science skills. But actually, those who have, they have an option to improve their models, and that's what we are actually building. And it will come in the next release of MindsDB.
That's quite cool. Would you like to share what kind of machine learning libraries, frameworks you used behind the scenes to implement MindsDB?
Sure. Actually, we have a separate repo on GitHub called Lightwood. And you can access it at GitHub/MindsDB/Lightwood. And this is the kind of engine we used behind MindsDB. This engine is built mainly on top of PyTorch. That's like state-of-the-art library with the Facebook behind it. And also uses some other libraries like the Lightgbm and so on. This is what we have inside. Please welcome to visit this repo and tell us what you think.
Okay. One thing I didn't get from Jorge's presentation. So I've seen him exemplify that. So you build a predictor model. That predictor model basically analyzes the data in a table to actually build the statistical model, and then you get the predicted data, of course, if you query it. What happens if the data underneath the model changes? Do you have to perform any maintenance to the model itself? Do you have to do anything to adjust to the changing data?
Yeah, good question. Actually, sometimes you need to retrain the model exactly because what you have mentioned, the data has changed. And like with MindsDB, it's easy. It's just a SQL statement. However,
you have to rerun the statement again.
Yeah, however, people might want to automate this as well. And we're also working on this feature that will come in one of the closest releases that would allow to automate this model retraining based on certain behavior in the data, or like some time related rules. For example, retrain each certain amount of time.
And so I get this, but so once you build a model on a table data set, so the model is created. Can you tune up the model after it was created, or you have to recreate the model again and select different parameters and things like that?
Okay, so if you really want to get into your hands-on into the model performance, like tune it, MindsDB allows to do this. We just announced a new feature called JSONAI just this September. Actually, this is part of our engine called Lightwood, as I mentioned previously. And so what it does is for each model, it generates a JSON type configuration file. So you can actually get into this file and edit it, edit some parameters of your data, features, or encoders, and so on, and actually tune your model. So you don't need to create dozens of models to find the best performing one. So you just create a model and you can tune it with a kind of declarative machine learning approach using JSON type configuration.
I see. That's nice. I also saw Jorge mentioning that for MindsDB, it's helpful that MariaDB requires a schema, obviously, for the data. So data is kind of has to follow some consistency rules, some format, which I know from my own experience. The quality of the data is quite important in easing the work you have to do. But does the MindsDB can MindsDB perform any data anomaly elevation in real time for the time series data that for the time series features that Jorge presented?
Yeah, this is a very good point, and we see we have several customers who are really in need for this feature and this capability to get anomaly detection in real time from like different sensors that might come, or in streams, or even in the database.
So this is some work to be developed?
No, it's already in place. So actually, for this multivariate time series detection with high prediction with high cardinality that Jorge explained, we are providing confidence levels for upper and lower bounds. And actually, when you make a prediction, predictor understands what are the maximum and minimum possible for this type of data, and it calculates based on the actual data that you have for this timestamp if it falls within the bounds or falls outside. And this means the anomaly. It's an anomaly flag. So it's really easy to do anomaly detection with MindsDB, and especially given this high cardinality multivariate time series data, you can just do it in a one SQL command, and it's quite straightforward.
It seems like a complicated problem to know what an anomaly is in the data, because from MindsDB perspective, you don't actually know what the data is. So it seems like a complicated problem. Does MindsDB have any ability currently to let the user specify what an anomaly is for the data?
Yeah, well, actually, how it works is that you have a historical table with your data, and you train a predictor for this data based on like certain amount of time looking back and forward, like prediction how many timestamps you want to make it forward, and then actually you'll do a left join of this predictive data with your table, and it adds kind of for your historical data, it adds those predictions like if they were done real time. Some time back, and it's based on the historical data. It's make a prediction, and if it falls outside of the bounds, it flags an anomaly. It's how it works.
I see.
You can actually watch some demos we have on YouTube and read our blog.
I'll try to research more the project. It seems pretty cool. Costa, you've done amazing work at MindsDB, and I really like the end result. I'm pretty sure that databases, they usually have a habit to do this. They put a lot of obstacles in your work, and building like AI capabilities on top of MariaDB. Is there something that MariaDB community, or especially the MariaDB Foundation, can do to help make your life easier, like in terms of features or in terms of bug fixes? Is there anything we can do to make you more productive in building your project?
Well, we really welcome any feedback, and we're an open source project. We're open to any feedback, and our community is available. Like you're always available to join our community and like tell us what you think, ask for help or anything like that. And just welcome to discussion. Any MariaDB users, what you really want us to help you doing with MindsDB, what predictive needs you have, and we'll come back to you. Just get to our community.
Okay. Thanks. Thanks a lot. And this was a great chat. Nice to meet you.
It was my pleasure. And yeah, thanks for inviting me.
Okay, see ya. Bye.
Bye-bye.
Bye.